Good afternoon, good evening. It's your boy Mr. Malaji and I'm back with another video. And in this video, we're going to be unpacking what arithmetic patterns are, how do we find the general formula of these patterns, and how do we use the general formula to predict any other number that is in that pattern. So let's first by defining what the word arithmetic patterns means. So these are just linear patterns, just a fancy word of saying these are linear patterns. And if you don't know by now, linear patterns are just patterns that have a constant difference. So these are patterns that have a constant difference. So what does that mean? Let's take an example. If I have 3, I have 7, I have 11, and I have 15. So this is my pattern. It's progressing in that manner. And if I investigate it, I will see that from the 3 to the 7, I am adding a 4. From the 7 to the 11, I am adding another 4. And from the 11 to the 15, I am adding a 4. So what does this 4 mean? The fact that this 4 is the same means that we have a linear pattern. The fact that this 4 is constant, the difference, this guy is called the difference. The fact that the difference is constant tells me that this is a linear pattern. So that's the definition of an arithmetic pattern. And like I said, in this video, we're really interested on what is the formula for this pattern? How do we go about predicting further numbers that pop up in this pattern? And really, how can we use that formula to actually find the 10th term, the 100th term, and so on, and so on, and so on. So let's take the same example. So how do we go about finding the general formula? So number one, we're trying to find the general formula for this pattern. Right? Before maybe we get that, let's just complete this pattern. So again, I'm adding 4 to the 15, I'm getting a 19. I'm adding a 4 to the 19, I'm getting a 23. I'm adding another 4 to the 23 and I'm getting a 27. So that's how you would complete that pattern. And again, to find the general formula, we need to understand this T-N formula here. So what does that T-N formula actually mean? The A in that T-N formula stands for the first term in the pattern. This is the first term in the pattern. So in this case, it would be a 3. That's what we're going to be substituting for A, the first term in the pattern. Then the D there is our constant difference. So this is the guy that we keep adding from term to term to term. And we've already established that it's a positive 4 in this case. Then what does the N and the actual T-N mean? So the N, this is the position of a term. This is the position of a term. So what does that mean? If I'm looking for the 10th term, then I'd come and substitute N as 10. If I'm looking for the 100th term, I would come and substitute N as 100, because that is the position that term is in. So again, N is position. Then this Tn here, the one we usually have on the left hand side, that guy is the actual term in the pattern. So what does that mean? It means that, for example, looking at this pattern here, if I came and substituted 5 for N, then 1, 2, 3, 4, 5, my Tn that will be coming out there will be 19. So the actual term in the fifth position is 19. If I came and substituted 6 for n, then the actual Tn that will be coming out, or T6, will be actually 23. So I hope that makes sense. This kind of explains what the formula is. And let's now actually find the one specific to this pattern. So let's do that. Just going to erase all of this. Just remember what those things mean, because it's very important. All right. So now I'm given this formula here, and I just need to substitute. So I say Tn is equal to my A is the 3. I substitute 3. The n, we don't substitute anything right now. We usually substitute when we're actually solving. So for right now, we just leave it open. Our D is the 4. Then what I need to do is I need to expand that. So 3 plus the 4 times is into that bracket. Distributes 4 times n is a 4n. 4 times a minus 1 is a minus 4. And if you expand this, it's a 4n. Your like terms, this minus that is a minus 1. So this is my final general formula for this pattern. How does that help us? If, for example, I wanted to find this 27. If I wanted to find that 27, I didn't actually have it already, but I knew which position it was. It's 1, 2, 3, 4, 5, 6, 7th position. Then I could take that guy and say T7, and wherever I see n, I'm going to substitute 7. Because why? I'm looking for the term in the 7th position. And if you expand this, 4 times 7 is 28 minus a 1. So T7 is actually the 27th that we have in the pattern. And you can use this formula. So I used it to solve for the 7th term, but you can use it to solve for the 10th term as well. So T10, that's question 2, solving for the 10th term. Let me write it out actually. Solve for the 10th term. And so T10, I take that same formula again. I substitute 10 for n. And if I expand this, that's a 40. 4 times 10 is a 40. And if you subtract, you get a 39. So what does this mean? If I go to the 10th position, the actual term I will find there is number 39. I hope that makes sense, guys. All right, so the next question that we're going to do is vice versa. When we are given the actual term and we're trying to find what position that actual term is in. So let's look at something like that. All right, so there's the question. It asks, which position is 91? So we take the same formula, Tn is equal to 4n minus 1. But this case, we're substituting the 91 for the Tn. So 91 that side. And if you solve for n, take the 1 over, do your inverse operations. That 91 is being added, so you get 92. And if you divide by 4, you will see that n is equal to 23. So what does that mean? It means the term in the 23rd position, is 91. Or rather, 91 is the 23rd term of the pattern. And so on that note, I hope this makes sense. I will do one more example, and then let's look at how we answer these questions with that one example. Alrighty, so in this example 2, we're given this pattern here. It starts with 13, 7, 1, -5, and we are asked firstly to complete the pattern. So how do we complete the pattern? We need to first find what is the relationship that keeps happening there. So here I see that they're subtracting a 6, they're subtracting a 6, and they're subtracting a 6. So they should be subtracting a 6 from there as well, and that will give me a -11. They subtract another 6, that will give me a -17. They subtract another 6, and that will give me a -23. So that's how you would complete the pattern. So the answer for this guy will be -11, -17, and -23. There we go. Then the next question asks you to find the nth term of the sequence. So if they ask for nth term, that's them asking for the general formula. And remember, general formula, we always start with this formula right here, where the A is our first term and where the D is our constant difference. So A is a 13 in this case. Our D is a -6 in this case. And if we substitute that guy, I'm going to answer it down here. If we actually substitute, it looks like this. Tn is equal to 13 plus n minus 1 with the -6. This -6 does the same thing. It distributes into this bracket here. So -6 times n is a -6n. -6 times a -1 is a +6. So be careful of that. And so if you do your like terms this time, 13 plus that guy would give me 19 minus 6n. So that is my general formula for this pattern. So to answer that question, let me just put it up here. My general formula for this pattern is Tn is equal to 19 minus 6n. Then we're asked to find the 100th term. So we're going to do C down here. Tn, let me just write the formula first. And now T100, remember, we substitute the 100 for the n. Remember, the n is our position. So if we substitute 100 for the n, I'm asking what is going to be the term in the 100th position. And if you do that in your calculator, you should get -581. So -581 will be the term in the 100th position. So T100 is -581. Then that's done. Then D, which term in the sequence is equal to -81? Again, we take our formula, but this time we're not looking for the Tn. We are instead wanting to solve for the n, the position. Where is this -89? So -89 will go there. And if you solve this equation, -19 minus 6n, and if you do those like terms, -89 minus 19 is a -108. And if you divide by -6 there, -6 there, n is equal to -108 divided by 6 divided by -6 is a +18. And remember, your n cannot come out to be a negative. You can't get negative positions. This pattern is moving up, so this guy should always come out as a positive number. So to answer this question, n is equal to 18. And there we go. So with these two examples, I hope it helps you see the types of questions you're going to be asked when it comes to arithmetic patterns. But also, I will be dropping a video where I do some past paper examples on arithmetic patterns. So please check out that video. And on that note, that's it from my side. I will see you in the next video. Bye.